Okay, I'm going to go with that practice one. I have to change a couple of those problems because just one of them maybe. Because there is one more theorem. It can be done, but it takes time. But so the one that I'm going to doing over here are the one that you have to know. Okay, but just one of them that you cannot do. So that's a practice. What we are going to do, we give you a couple of questions finding this Laplace transform, Laplace inverse, or types that we talk about it. Okay, the type ordinary one, partial fractions. Okay, we did quite a lot. And then we give you a couple of differential equations to solve. Okay, differential equations are going to be a type, we call it the type one. Okay, you have 4 over here. Then I may give you a couple of more. So because the one here are all homogeneous. So let's see how far we can go. Okay, so this is going to be practice quiz number 3. Okay, I do the one that it's possible to do. Okay, and if we get time, then I may give you more. So the first one, we want to find the Laplace transform of each function. Find the Laplace transform of each function. You can bring your tables if you like, but the one that we're going to give you are the type that you have to use those theorems that we talk about it. Okay, so it's not going to be directly on the table, so you have to do it yourself. Yeah, okay. So if you just give us the answer right away, we won't give you a point. So you have to prove it. You prove it either by using the definition of the Laplace transform, or you are going to prove it using, these special theorems. Okay. So I'm going to show you how we're going to do it. This is going to be part B. Part 1, we do it later. If you do it now, it takes quite a lot of time. Okay, let's say if we get time, I'm going to talk about it. Part B, just ordinary one. F of t is equal to the t cubed plus 2 u2t, okay, minus 5 u4t. That gives you the hint what type of function we are interested in. Okay, they are unit step functions. So find the Laplace transform. Solution. So the Laplace transform of f of t is going to be equal to 1 by 1. It's going to be Laplace of t cubed. Yes? Yeah. Okay, Laplace of t cubed, thank you. Plus 2 Laplace of u2t minus 5 Laplace of u4t. Okay, just use the formula for each one of them. Laplace of t cubed. Remember, what's the Laplace of t cubed? 3 factorial. 3 factorial over s to the 1 up to the 4th. Okay, you have the formula, you can use it. Laplace of t to the n factorial over s to the n plus 1. Plus 2, this is just a unit step function, UCT. UCT, remember, e to the negative 2s divided by s, ut, minus 5 unit step function with the base 4, e to the negative 4s divided by 4. That's it, simplify a little bit. 3 factorial would be 6. What's that? Divided by s, you are right, divided by s. Okay, 3 factorial would be 6. 6 s to the 4th plus 2 e to the negative 2s divided by s minus 5 e to the negative 4s divided by s. That's it. You don't have to simplify further, you accept it. So that would be the Laplace of f of t. Okay, so the purpose is just to see how you work with the unit step function. That is the first one that we can do. We stay with unit step function. Part E, we did it before, but I just explained it again. Part E, the function is h of t equal to, that's the one that we just did, 0 when t is less than 2. Again, that gives you the hint that we are interested in this group. T minus 2 squared when t is greater than or equal to 2. Of course, you change it to the unit step function first, then you do it. It can be done directly, but don't do it. Integration by parts. Yes. That was the one you talked about. Okay, let me do it again. Let's see. Okay, write it down as a unit step function first. Remember, unit step function 0, 1. So factor out the t minus 2 squared. So h of t is equal to the t minus 2 squared. The leftover 0, 1. T less than 2. Greater than or equal to 2. You know that this is, what is this function? Is u2 t. u2t, t minus 2, all squared. Now it's ready for the, for the action. Because this is ut, your function, you see, this is automatically f of t minus 2. Drop the 2, the function is t squared. It's the way we do it. This one way to do it. Okay, so the Laplace of, this is it, Laplace of u2 t minus 2 squared is equal to, because of the u2t is just e to the negative 2s. I just explained it, times the Laplace of t squared, your function, f of t. What is Laplace of t squared? 2 factorial over t cubed. So the final answer would be 2 e to the negative 2s over t cubed. So that would be the Laplace of h of t. Sorry, over y over t. S cubed, s cubed, s cubed. I have to rewrite it. 2e to the negative 2s, s cubed. So they are all will be in terms of the unit step function, because for the rest, we have the, we have the formulas. That is part E. We can do part F. Part F. So what is the part F? The function is h of t equal to, is equal to the cosine of t, t less than equal to 1. Then it's a t minus 1. T minus 1 plus a cosine of t, but t greater than equal to 1. Again, of course, try to change this one into unit step function and just find the Laplace transform. Don't try the direct one. You can do it, break the integral of 0 to infinity into the 0 to 1, 1 to infinity. That takes quite a while to be able to do it. Okay, any suggestion? We change it to the unit step function. Subtract cosine first. Okay, you pull out the cosine. Solution. So it's going to be h of t equal to, we write cosine of t plus leftover. What's going to be leftover? 0 and t minus 1. When t is less than equal to 1 and t greater than equal to 1. But for the unit step function, you need 0, 1. Or pull out t minus 1. Okay. So it's going to be equal to cosine of t plus t minus 1. The function now is 0, 1. T less than equal to 1, t greater than equal to 1.
Would it be only less than? Like t less than 1?
In that case, yeah, it's 1. One of them is, yeah, the first one is just t less than 1. It's a misprint here. Okay. Now, you know that this is going to be what? U1t. So it's going to be cosine t plus t minus 1 U1t. You see, it's nicely matched and can be taken care of quickly. Now let's find out what is the Laplace of h of t. Laplace of h of t is going to be equal to the Laplace of the first one, which is the cosine. So Laplace of cosine of t plus Laplace of t minus 1 u1t. Again, the second one is nicely matched, u minus c uct. So the first one, Laplace of cosine. What's the Laplace of cosine? S over s squared plus 1. Okay. And the next one is nicely done. S on the top. Okay, s over s squared plus 1. The second one, the function f of t minus 1 is t minus 1. You drop the 1. The function is t. Laplace of t. So it's going to be plus. Because of the u1, it's e to the negative s. Laplace of t. 1 over s squared. Yeah, t is 1. N is 1. Is n factorial over s to the n plus 1. S squared. Okay, so the final answer is this one. S over s squared plus 1 plus e to the negative s over s squared. So that gives you the final answer. Okay, so we are interested in this type that you get the UCT, you get these numbers. And there is another group that we can do it quickly, but we won't have time. So these are the one for these quiz. When we get to the test, we come back and we finish it. Because you won't get time to do it, and I don't have time to go over it. Okay. Now the second group. Second group is the Laplace inverse. You get more over here, okay? The one that mostly you have to do the partial fraction one, and the one that you have to do this method of tonight. Okay, so let's do it. Again, there is one of them that I have to change it. But we can't do it now. So, second question. You give a couple of this function to find the Laplace inverse. So find the inverse. Okay, find the inverse Laplace transform. Laplace transform of each function of each function. Okay, just again a couple of standard one. There's going to be two types. The type 1 classic, the other one involving the unit step function. Okay, so the first one is kind of straightforward. F of s equal to f of s equal to the 2s minus 3 over s squared plus 4. There is no e to the negative cs, so this is not going to be involved any unit step function. If you see e to the negative cs, that would be the unit step function term. So it's a classic. So the bottom is s squared plus 4. Okay. So what I'm going to do? we separate it. You see, because s squared plus 1 is not factorable. On the top, you know that. If it's on the top, it's going to be s over s squared plus 4, that would be cosine. If there's going to be a number, would be sine. We have the s and the numbers. So break this one, write it down as a like fractions. Solution. So fs is equal to the 2s over s squared plus 4 minus 3 over s squared plus 4. Now we are ready. The first one should give us the cosine. The second one should give you the sine. And you may have to modify the second one. Okay, so Laplace inverse of fs is going to be equal to the Laplace inverse of the first one. It's a 2s over s squared plus 4 minus Laplace inverse of the second one, s squared plus 4. You know that the first one is cosine. You pull out the 2, the leftover is going to be 2 cosine of the 2t. That's the first one. For the second one, what's missing? You need a t on the top. So we create the 2 on the top, minus 3/2 Laplace inverse of 2 over s squared plus 4. It's like integration, you know, it's a linear function, so we can move around the constant. So that give you 2 cosine of the 2t minus 3/2. This is going to be what? Sine of the 2t, and you're done. So that would be Laplace inverse of f of s, and we're done. Okay, so it's going to be the kind of classic one that we have.
How you factor out if you got 3/2 and then 2 on the top.
I need a 2 on the top. So I multiply by 2, divide by 2. It's like integral when you do your substitution. Because the 2 and 2 would cancel out. If you need a 5, you divide and multiply by 5. Okay, that's one. The second one is the one that just we did. So just check the solution yourself. We give you 1 with this property, okay? This is a kind of e to the negative 3s. We just did this one. S squared plus s minus 2. You see, oh, that was a negative 2s. We can do it quickly just to see. We give you one of these type. As soon as we see the e on the top, this must involve the unit step function. So you have to find the Laplace inverse of that function first, and then come back and take care of it, okay? So this is the way we are going to do it. So you have to do the partial fraction of the bottom one first. Solution. Okay, so let's take care of this. S squared plus s minus 2. Remember, as we did it, it's s plus 2 times s minus 1. 1 on the top, and this is s plus 2 plus s minus 1. Remember, we did it, and the number that we got is negative 1/3 and the 1/3. Okay, this is what we got over here. Now we go back and we check this Laplace transform. So in this case, if you find the Laplace inverse of 1 over s squared plus s minus 2. Remember, again, we did this one. The first one is negative 1/3 e to the negative 2t. And the second one is 1/3 e to the t. Remember, that's the one that we call it f of t. But your function would have a factor of e to the negative 3s. So the Laplace inverse of the given one, f of s, is going to be equal to what? u3t f of t minus 3. That's it. You already got f of t. You replace the t by t minus 3 and be done. So it's equal to the u3t Okay, just change those. Times it by negative 1/3 e to the negative 2 times t minus 3 plus 1/3 e to the t minus 3. That would be the final answer. When we get to the final, we said this is f of t. So we write the answer in terms of f of t minus 3, and then we done. What's that?
Why is it minus 3, not minus 2?
Because it's e to the negative 3s. Because the base is 3. Yes.
Hypothetically, if on the quiz there's like a really long question, and we didn't have enough room to use rate, I could write it like t equals t minus 3 instead of plugging it all in.
Yeah, we did. That is usual fact, the usual term that we do it in future. As soon as you find f of t, then you write the final answer is Laplace inverse of f of s is u3t ft minus 3. We accept it right away. Because these are the ones you're going to see it when we get to the differential equation. We do it, yes, we accept it. But your notation must be consistent. F of t minus 3 done. Because that's algebra. We're done with the solution. Okay, so this is it. F of t, Laplace inverse. U3t ft minus 3, done. Okay, that is the one. Any question? So for part C, you have to wait because the denominator is not factorable. We did one more theorems, and that would be too much for tonight. Okay, let's go quickly to the differential equation. That's the one. Okay, we give you two differential equation, and we have 4 here. Let's see if we can do it. And then I should give you one more because they're all homogeneous. We need one more, which is going to be non-homogeneous. Okay, now you know that you have to do all these operations in one differential equation. We are not going to give you anything with the, okay, those you need a step function now, but you will see it in future. Number 3, solve differential equation, of course, by Laplace transform. Use the Laplace transform. You got to be patient, okay, but otherwise it's not a difficult problem. Use the Laplace transform to solve the equation, okay, to solve the equation. Yeah, you can read the linear. There are some special cases, but linear only. Linear with the initial condition. They are homogeneous, but you can have non-homogeneous, which would be more fun, okay? So the first one, we give a couple of them, at least 2. Okay, y double prime, y prime minus 6y equal to the 0. Initial condition, y of 0 is 1. Y prime of 0 is negative. Okay, you know that. Ordinary case, you just find the characteristic equation and you do it right away. But it's a Laplace transform. Now the way we do it, remember, we are going to call our function solution. You are going to suppose y equal to f of t is the solution of the equation. Is the solution, okay, of the equation. I change it. Some people, they don't change it. They stay with the y of t, but I don't. So the initial condition now is going to be f of 0 equal to 1, f prime of 0 equal to negative. Remember, take the Laplace transform of both sides. So it's going to be Laplace of f double prime of t minus Laplace of f prime of t minus 6 Laplace of f of t equal to the Laplace of 0, which is 0. That's a step 1. Taking the Laplace transform of both sides. Now you are going to change all the Laplace of the derivatives into the Laplace of the function because of that theorem that we have. Remember, one by one. The first one. Second, remember the way we do it? It's going to be s squared because of the second. S squared. Laplace of f of t we lower the power of the s, we multiply by the f of 0, f prime of 0, f double prime, etc. So you lower the power minus s, f of 0. We continue. We lower the power of s. The next one is s to the 0, which is 1. So the function would be f prime of 0. You're done. So you start with the highest power, which is the order of the derivative. You keep going down, then you usually it's a second derivative, you end up with the first derivative. That's the first one. You repeat it for the second one. Minus second one is prime. So the power of s would be 1. S, L of f of t. Lower the power of s. Then you lower it, it's going to be disappear. Okay? So it will be only minus f of 0. That's for the prime. Okay, and the next one is 6 Laplace of f of t equal to the 0. Now apply the initial conditions. Initial conditions are what? F of 0 is 1. F prime of 0 is negative 1. Nothing would disappear for this one. F of 0 is 1, so this is times 1. F prime of 0 is negative 1. Sorry, that's a negative 1. So this would be negative 1. And f of 0 is 1. Carefully substitute. What's going to be the result? Okay, the result would be, the first one would be s squared Laplace of f of t. This would be f of 0 is 1 minus s. This is negative 1. Negative would be positive, plus 1. Minus s Laplace of f of t. Okay, this is f of 0 is 1. There is a negative here, minus 1. Minus 6 Laplace of f of t equal to the 0. Okay, carefully substitute. Now you are going to factor out Laplace of f of t. You see, 1. They are not going to be simplified. So this is going to be factoring it out. So what's going to be the leftover? S squared from the first one, negative s minus 6 Laplace of f of t. You check to make sure that this is a characteristic equation of the homogeneous equation. You see this one? Look at this one. So it's the same thing. R squared minus R minus 6. If it's not, you made a mistake. You go back and double check it. Yes?
Should it be +1 and then +1 again?
I check it. So this is negative would be positive for the f prime of 0. And this is f of 0. F of 0 is 1. So that gives me negative, which is positive. You are right. That's it. Very good. So what's going to be the leftover? The leftover is minus s. You get a 1 and 1, 2. 2, nothing else, equal to the 0. Remove the anything else to the other side. S squared minus s minus 6. Laplace of f of t is going to be equal to the s minus 2. Solve for the Laplace of f of t. So the Laplace of f of t would be what? S minus 2 over s squared minus s minus 6. So you factor the down. Yes, what's that? Okay. So this is what we got so far. So factor the denominator to get the rest. Just one that I have. That's it. So far, so good. So denominator, factor it. S minus 2, the numbers. S minus 3 times S plus 3. So you have to do the partial fraction, take care of that, and then you take the Laplace inverse to get the final answer. Okay, there you are. S minus 2. over s minus 3 times s plus 2. It's going to be something like a and the b, if you like. I call it a1. a1 s minus 3 plus a2 s minus 2. You have to go to the common denominator to find it. I'll give you the solution, you check it for yourself. A1 would be a fifth, and the A2 would be 4/5. Okay, it's gonna be done by the shortcut, but you know, because it's s minus 2, you better cross multiply it and find it quickly. Okay, so that's it. We are ready to get the result. So that's Laplace of f of t. Now it's going to be equal to the fifth s minus 3 plus 4/5 s plus 2. So we are interested in the f of t Laplace transform, Laplace inverse. So that gives a Laplace inverse of a fifth over s minus 3 plus Laplace inverse of 4/5 s plus 2. You know that they are all e functions. So nothing to worry about. So the first one is 1/5 e to the 3t. And the second one would be 4/5 e to the negative 2t. This is the solution of the equation, and we're done. Okay, so it's a nice one to get through it. That is case 1 that we did have. Okay, any question? So we give you one of the second order, and the other one's going to be one of the higher order. Yes. No. Confused about what? For partial fraction, you have to do it. You see, you call it A1 and A2. You cross multiply A1 times S plus 2. S minus 2, it's a negative S plus 2. So we move it to the other side, that gives S minus 2. Okay, it's always the case. You have to move it. That is going to be. Okay, I'm sure that the solution is correct.
The f minus 2 went. I think you didn't realize that it goes away after the part.
Yeah, we're gonna. Okay, this is a homogeneous one. Let's do one non-homogeneous, because there was a 0 on the other side. So the non-homogeneous one is part C. Initial condition are missing. I'm going to give you initial condition. So to give you one homogeneous, one non-homogeneous. Let's see. You don't have it. Okay, let's write this one. This is non-homogeneous with the cosine. We give you one non-homogeneous one. So this is a kind of candidate. So let's do it quickly. Solution. Take the y to be equal to the f of t. F of 0 is 1. F prime of 0 is 0. Quickly substitute. That give you Laplace of f double prime of t plus 9 Laplace of f of t equal to the Laplace of cosine of the 2t. Okay. Change f double prime. S squared Laplace of f of t minus s f of 0 minus f prime of 0 plus 9 Laplace of f of t. You know the Laplace of a cosine is what? S squared plus 4. Apply the initial condition. What do you have? F prime of 0, 1. F prime of 0 is f of 0, 1, f prime of 0, 0. So what's going to be the result? This is 1. This is 0. So left over s squared Laplace of f of t. F of 0 is 1, so minus s. This is 0 plus 9 Laplace of f of t equal to the s over s squared plus 4. Factor out the Laplace of f of t. So that gives you s squared plus 9. You check that s squared plus 9 is a homogeneous characteristic equation of r double prime, y double prime plus 9. So we are on the right track. So this is going to be equal to the s over s squared plus 4 plus s. That's it, yeah. Now divide by s squared plus 9. Laplace of f of t equal to, if you divide that, give s, you already got s squared plus 4 times s squared plus 9 plus s over s squared plus 9. Don't combine them together as is, you divide, because the rest is going to be easier. You see, this can be done, but the other one, you did have some difficulty. I can show you the other one. You see, this is the other one. The other one, when we do it, then we be in trouble a little bit over there when we put them together. So you end up with something like e to the cosine, e to the sine. This is the formula that we don't have it at the moment. That's why I didn't continue. But this one, I can continue at the moment and get the result. Okay, what are we going to do to get the Laplace inverse? This is easy. The Laplace inverse of this one will be cosine of the 3t. You have to take care of this one. Quickly, you have to what? Partial fraction to get this, okay? So we do the partial fraction of this part first, and then be able to do the, okay, to get the last part. So what is going to be the partial fraction? I just want to find the numbers. So it takes a little bit of time, but it's worth it, okay? That's it, you have no other choice. S squared plus 4. Those non-homogeneous one takes times. There's no easy way. Okay, you get s squared plus 4. You get s squared plus 9. You know that on the top, you have to put a linear one. So you have to put something like a1s plus a2, a2s plus a3 to get the partial fraction there. Because the bottom one is quadratic, the top one must be a linear. Always one done. Get the, okay, get the common denominator to find it, to get the result. So how are we going to find it? Is going to be, that's s squared plus 4 times s squared plus 9. Now the top would be a1s plus a2 times s squared plus 9 plus a2, a3, a3s plus a4, 3, 4 times it by s squared plus 4. You let the top two cut each other and you find these numbers. Probably you have done this type of operation for the integration in calculus 2. We have the same one for integral. That gives you A3s plus A4 times it by s squared plus 4 equal to the s. You see the difficulty with these equations are you don't have any nice numbers. S squared plus 4 is not factorable. S squared plus 9 is not factorable. You remember how we're going to find these four? A1, A2, A3, 4? Which one? Excellent. That's it, yes. You match the coefficients. Because if you want to put the numbers, it's messy. Because you have four numbers. Okay, how are we going to match the coefficient? You multiply to get these coefficient of the same power together. Okay, if you multiply, the highest power would be S3. Okay, so I'm going to collect the coefficient for the S3. If you multiply these two together, that give you A1 as the S3. And if you multiply these together, that give you A3. So that would be S3. Then I collect the one with the S squared. I got the A2 here, S squared. Then I got the A4 here for the S squared. Then I did the S. There is no S. So that's done. And sorry, there is a S, yes. There is a S. 9A1. You get the S and 4A3. S. Constant. 9A2 plus 4A4 constant equal to this. If you match the coefficient, there is no x cubed on the other side. So A1 plus A3 would be 0. There is no s squared on the other side. A2 plus A4 equal to the 0. The coefficient of s on the other side is 1. Okay, and the constant term, there is no constant term on the other side. 9A2 plus 4A4 equal to the 0. That's it. You know that you get a system of 4 equations, 4 variables, but you don't need to use the matrix to do it. Okay, you consider it 2 by 2, then you'll be able to find those coefficients easily. Okay, so for example, you consider these two together, 1 and the 2. You consider these two together, that give you A1 and A3. You see get A1 plus A3 equal to 0. And you get the 9A1 plus 4A3 equal to 1. This is it. You solve this system and the other one. So the other system is going to be A2 plus A4. You can use addition method to do it. Equal to the 0, and that gives 9A2 plus 4A4 equal to the 0. Okay, if you solve it, this is the final answer. A1 would be a fifth. That is A1. B would be 0. C would be negative 1/5. And the D would, sorry, I mean A2, A3, and A4. Okay, A1 is 1/5. A2 is 0. A3 is negative 5th, and the A4 is 0. So you go back and you just do your partial fraction types, and then it's going to be lots of sine and cosine, and you'll be able to do it. So if you're going back and write it down, it's S over S squared plus 4 times S squared plus 9 is going to be equal to A1S. A1 is a fifth. 1/5 of S. 1/5 of S over, okay, over S squared plus 4. Plus, okay, A1S because the A2 is 0. Then plus the other part, A3. A3 is negative 1/5. A4 is 0. So that gives you S squared plus 9. So you nicely change it to this one. The first one is cosine, the second one is sine. And then you'll be able to do it. But there was another term, s over s squared plus 9 here. Okay, look at this one. We did have 3 terms. So the final answer, f of t, is going to be Laplace inverse of 1/5 of s over s squared plus 4. Okay, plus Laplace inverse of negative 1/5 over s squared plus 9 plus Laplace inverse of the last one, s over s squared plus 9, because that term was a leftover from the previous part. So all of them are the famous function. The first one would be 1/5 s over s squared plus 4, cosine of the 2t. The second one is negative 1/5. What do you need? You need a 3. So it's going to be 1/3 sine of the 3t. Which one? Oh, yes, thank you. There is a s here, s. So it's going to be just, thank you. You have the s in both of them, yeah. So it's going to be negative 1/5 cosine of the 3t. And the last one would be, so we get the cosine and the cosine. Yeah, all of them are going to be cosine. And the last one would be what? Cosine of the 3t. You get a 1/5 and the cosine of the 3t, you can put them together. It's going to be 4/5. So the final answer is this one. It is a 1/5 cosine of the 2t. And this would be 4/5 cosine of the 3t. This seems to be the final answer. Again, non-homogeneous one takes times. This function was ordinary one. But we are going to have those unity step function around. So you got to be very patient for the others. But we can do it. Get the experience step by step. Okay. So we give you a group of them for the time being, just to practice. Then we come back and we have 3 more, we need 3 more theorems, formulas to be able to take care of all of them. Okay. And that's it. So we have the quiz and then we continue for the Laplace transfer. Good man. I have a question. Yes. It is.